Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my Pennsylvania A3 switcher this week, and I know the chooching last week is a tough act to follow, but we're going to make some infrastructure to get ready for building all of the cab controls that are going to go on the back of this thing so we can drive it. So let's go. Well, you may recall we have this radius arm here on the valve gear that moves up and down to set the valve hookup and also go in reverse. Now we need a way to control that from the cab. That's done with a series of linkages, and those linkages need something to attach to, and that's the footboards that go up here, also called the running boards. So let's get started on those. I've got this nice piece of brass bar that I purchased some months ago, I think for this purpose. One of the challenges of this project is that I do periodic material orders, typically months in advance of when I actually go to make these parts, and then I forget what all the materials were for. I suppose I could go through and label all of it, but what's the fun in that? This seems to work, so I'll use it. This bar stock is pretty close to the final running boards nominally. It's the right thickness and a little bit wider than necessary, so I just need to cut a couple of lengths of it. I'll rough cut these and then finish them up later. Now it's later, so I'll finish up the ends on the milling machine and bring them to final length. One of the fun things about these parts is that they are an excuse to use my super caliper. This was donated to the channel a while back by a viewer. It's a 24-inch vernier caliper. I don't often get to use it because I rarely make parts this big, but I do love a chance to use my super caliper. Not that these footboards need to be accurate to the thousandth, of course, but I'll take any excuse I can get to use super caliper. It's also a good excuse to keep my vernier scale reading skills sharp. One can easily get spoiled by dial and digital tools, and, well, you still need to know how to read verniers someday. Our parents went to the moon with slide rules, so I have no excuse for not being able to read a vernier to make model footboards. After double checking the width on the drawings, I decided, there's too much material here to turn into chips, so I'll mark the width that I need to rough cut off of this, and go back to the bandsaw and rip that off. The bandsaw is a whole lot faster than the milling machine, and bandsaw blades are a whole lot cheaper than milling cutters. The more hobby machining I do, the more I try to make every milling cut just a finishing cut. Speaking of which, I will finish up those bandsaw cut edges now with this setup that I use for milling sheet metal and thin bar stock, that sort of thing. It's a fixture plate that I put in my vise, and I can use fixture pins and parallels and such to set things such that they hang off the edge of the fixture plate, and I can mill the edge of them with very little vibration. This is a really good setup that's working well for me. Now I'll grab my Heimer edge finder, and I'm going to find a corner here. I'm going to mark this as my little origin. This lower left corner is where most of the holes that I need to now drill are marked from in the drawing. Each of these footboards has quite an elaborate hole pattern drilled in it that I'll spare you watching all of. It's for mounting various things, various cab controls and the cab itself, and there's some linkages, and I think the air compressor tank mounts underneath, so a whole bunch of stuff. As you can see, I've got a system of machinist jacks and strap clamps set up to work on the ends because this part is so much longer than my vise. But by doing it this way, I can use one origin and not have to re-edge find by shuffling the part around in the vise. So when I need to work on the other end, which is also sticking out, I shuffle all my jacks and clamps to the other end, and I can do my work there without ever losing my origin that I found on the DRO. This is much more accurate and much faster than shuffling the part around in the vise. Then when I need to work on the other side, I use an end stop to flip the part, and I maintain my x-axis now on the DRO, but I do have to remember that my y-axis is now flipped, and I need to work on the back because some of these holes get countersunk from the other side, depending on which way the screws go into the components. And this is something that I screw up a lot, so I'm proud to say I think I managed to do all of the countersinking on the correct sides on these parts. Boy, a good countersink never gets old, does it? The right side footboard gets a notch cut into it, which I believe is for clearance for the linkages that connect to the quadrant and the reversing lever, which is how we will actually be controlling the valve gear. I think we'll be starting on those linkages next time, but for now we just need the notch. Those footboards are going to be going on there like so. They sit on top of the motion brackets, and then there's some bracketry that holds it to the rear bolster. So we need to make that next. I'm going to dig through my scrap bin and try to find some pieces that will work. I'm going to lay these out, both because extreme precision is not really necessary here, and also because they're a bit of a funky shape and I want to kind of get my head around them. So I'll first lay out some rough outlines of these parts, and I'll cut them up on the bandsaw, approximate the dimensions as it were. I want to clean up those edges and bring them to outer dimension, and I thought, well, why don't I do that on the shaper? That would be a fun job to do here. I haven't tried cutting brass yet on this machine, and this is a pretty simple job, so it's a good excuse to get some practice. I don't actually have the correct tool grind for brass on this machine. This tool has about a 5-degree top rake on it, and the tool holder also has a few degrees of rake in it, so I've got probably 10 degrees of top rake, which is 10 degrees more than brass wants, but I'll give it a try anyway. And yeah, it seemed to be working fine. I actually had rather a lot of material to remove. I overcut these quite a bit on the bandsaw, but the cool thing about the shaper is, for its size, it can take extremely heavy cuts. These are 50 thou passes that I'm doing, and honestly, it's not even flinching at this. I think it could do twice this all day. It's actually cutting very, very nicely, even with the wrong tool grind. The finishes it's leaving are pretty spectacular, I have to say. For this basic operation of squaring up the sides and bringing it to dimension, honestly, I don't think that was slower than the milling machine. I think that was just about as fast. This machine cuts slower, but it's much quicker to set up. Setting up the milling machine is very time consuming. There's a lot of fiddling with collets, and you got to move the head up and down 7 times, and it's a lot of cranking the table back and forth and so on. So the shaper is quicker to set up, but of course is slower cutting. I'm going to cut the ends of both pieces at the same time, which is, never super recommended. You don't necessarily want to clamp 2 parts in the same vice jaw like this, but if you know they're very close in dimension, as these are, then you can clamp them both together with some pieces of paper, and that will take up any slight variations in the clamping force of the same vice jaw spread across both parts. And that worked out great. I was able to clean up the ends of both of these parts very efficiently. The shaper really benefits from these multiple component setups. You get a lot more efficiency out of it. So with all the edges cleaned up and brought to outer dimension, now I'm going to do some layout. I'm going to mark the ends, which have some bracketry that mount to them, and then there's a tapered side on one side of each part. The bottoms of each of these is slightly narrower. So I'll mark that taper transition point and then lay out the taper itself. These parts are handed, so I got to be very careful to keep them different from each other, if that makes sense. Got to make sure I'm keeping a left one and a right one. That's another thing that I screw up all the time, but I seem to have done that correctly so far. For those taper cuts, I am going to cheat and do this on the milling machine. It is a lot easier to do these cuts on the mill. You certainly could do them on the shaper, but because there's little straight sections at the bottom with an inside corner where it meets the angle, you would have to do this cutting sideways on the shaper. So a lot of tiny little strokes effectively. And that would certainly work, but it would be very slow and tedious to set up, and the mill could knock this out really quickly. Now, if I was an intrepid 1960s model engineer with my shiny new shaper and no milling machine, because they didn't exist yet, then I would be doing this probably with a file. And in fact, if you're a 2025 model engineer, you could very well do this with a file. There was no particularly good reason to do this on the mill other than it was already here and it was already set up from previous cuts, so it was quick. So I mill that down to my layout line, being careful not to cut into the wider section at the top where that inside corner is. I kind of snuck up on my layout line there a little bit at a time, kind of picking at it with a file until it looked like I had the contact point correct there. A little bit of deburring, and I think you can see the effect now, where the bottom is a little bit narrower and then there's a little bit of taper. Kind of a nice little detail. For those of you keeping score at home, this is the finish off of that milling cutter. It's okay, kind of mottled, not fantastic. Meanwhile, the side that the shaper cut is blindingly shiny. It hurts to look directly at it. Now, you can get a lot better finishes than that off the milling machine. I'm not going to say the shaper always cuts better, but I find actually quite a bit easier to get good finishes off of a single point cutter, like on the lathe and like on the shaper. I have to apologize again for the wobbly bench. This is ludicrous speed on the shaper. This is the smallest pulley and a 4-inch out of 7-inch possible stroke. So this is pretty close to as fast as the machine will go. And with that crazy reciprocating mass flying back and forth, it is vibrating a lot on my bench. However, not as much as it appears. It helps to understand the optics of macro lenses. Imagine it like trying to balance a golf ball on a basketball. If you move even the tiniest amount, that golf ball is going to start to roll off the side and then accelerate very, very quickly off at the side. That's kind of what light does in the highly spherical optics of a macro lens. There's a lot of barrel distortion, which means that things close to the lens moving laterally look like they're moving much more and much faster than they actually are. Here's that same motion from a wide shot. You can see that yes, the bench is moving, it is wiggling a bit, but not nearly as much as it appeared to be in the tight shot. Remember, cameras are not windows into reality. They are a fiction created with a lot of complicated optics that often lie to you about what's actually happening. That's not to say this bench isn't still moving more than I would like. The whole thing is cribbed up on 4x4s, which has proven insufficient to contain the wild spirit of the shaper. I'm pretty clearly going to have to build a heavy steel bench and bolt it to the concrete to fully immobilize this thing. But that's a project for another day. While I was yammering at you, the shaper was making these little pieces which form the upper L shape on the vertical brackets. I also drilled and tapped these for some number 0 screws. These are going to be for silver solder fixturing. Those top edges are going to be lined up, and then I've left the sides of it long so that I can file them down to shape after silver soldering, just in case they move a little bit or something. Over to the hearth then. I got some flux on there, I got some silver solder on there, and let's get some heat on there. These little assemblies are really fun to silver solder because the smaller the parts are and the simpler the joints are, the easy silver soldering is. So you can really enjoy the process and kind of makes you feel like you're good at the process. And then you go and build a boiler and you find out how terrible you actually are at life. Boiler building is very demoralizing, I'm not gonna lie. Pickling and cleanup later. We've got this now, so let's get to that filing that I alluded to earlier. I'll start by filing down the ends to be nice and flush with the vertical part of the brackets. Then I file the heads off of those fixturing screws. They've done their job, so they can go away now. If this was a boiler, we would have to ensure that silver solder had made it all the way through all of the little threads on these fixturing screws. But I can tell you right now they didn't, but that's okay because this is footboard bracketry and not a boiler, which will explode if you don't do it right. Those, it came out pretty nice. I'm pleased with that. Those pieces that got soldered to the top now are effectively one with the vertical piece, so we can drill and tap the mounting holes for the footboard in those anywhere that we need to. A silver soldered assembly like that drills and taps just like solid brass. Next, I need a pair of L brackets that mount those vertical pieces to the bolster at the back of the locomotive. And I thought it would be fun to try and make these on the shaper. Found a piece of square bar that's a little bit oversized, so I start by planing it down to final dimension on all 4 sides. And then I'm going to carve the L shape out of it. Now, this is a trickier operation than I have yet done on the shaper, so this will be good practice. I'm going to cheat and I'm going to use this straight-sided tool as a form tool to create the L shape. So I'm lining up the edge of the tool, get it vertical with the work, and I'll use this to create the vertical face of the L. Then I'll lock that down and I'll make a series of roughing passes across, stopping a little bit short of the final dimension for the vertical leg of my L. I'm power feeding here, so it's easy to go too far. I'm leaving myself plenty of safety margin on the L shape so I don't cut too far and lose my dimension. I made a series of passes downward until the bottom of the L was the correct dimension, and then I measure how much more I have to go on the vertical part. And now I slowed the machine down and I'm feeding by hand, and I'm just sneaking up on that dimension for the vertical side. With slow hand feeding, I can take nice big shavings off the entire side of that piece all at once. It's actually very satisfying. Now, as I said before, this is cheating. If squareness of this face was really important, then you have to do it with a single point cut, which would mean a vertical cut on the shaper. I demonstrated that earlier when I made the rolling road. Just like on the lathe, when squareness is important, you want the machine slides to dictate the surface, not the edge of the tool and the grind on your tool, which is what I'm doing here. But absolute squareness is not critical for the inside surfaces of this part. So using the edge of the tool that way was just fine in this case. Sneaking up on that dimension now, and that was pretty easy because I was going slow and feeding by hand. I gotta say, the result from that is pretty phenomenal. The surfaces on this are all outstanding. There's even a little scale model fillet in the inside like you'd get with a full-size angle iron, of course from the nose radius on the tool. Boy, that did a nice job. Now, I'm not going to sugarcoat it. I mean, that took probably an hour, and on the milling machine, I could have made that L-shaped cut in 20 minutes, but it was fun to do it on the shaper, and I'm getting faster at it as I learn the machine, so some of that slowness is not the shaper's fault, but that was a lot of fun anyway. And hey guys, it is okay for things to just be fun. Let's not lose sight of that. I did, however, clean up the ends and bring them to final width on the milling machine because that was probably 10 times faster than doing that part of it on the shaper, and then I drilled the hole patterns and did all the countersinking and so on in these. Once again, I'm doing 2 parts on the same vice jaw here, which is not ideal. One of those parts is not getting clamped as firmly as the other one, just because of physics. However, all I'm doing is drilling some very small holes, so there's no significant tool pressure, nothing that's going to dislodge these parts. Now this is different than when you use 2 parts in a vice jaw to balance the clamping force, like if you're working very close to the edge of one jaw. That's a common technique. In that situation, you're taking advantage of the fact that the clamping on the 2 parts will be different by putting a part that's equal to or slightly greater at the far end of the vice jaw to ensure that the part you're working on gets clamped tighter, because then the vice jaw is working like a strap clamp. You're using a part at the other end of the jaw like the heel. But that heel piece will not be getting clamped as well. When working on 2 parts like this, one of these is effectively the heel, and I don't know which one, so don't push your luck. Some of these holes need countersinking as well, so I have an even smaller D-bit countersinking tool than you saw earlier that I use for tight spaces like this. I don't use this one all the time because it doesn't have quite as good a grind on it as the other one. I did a better job grinding the first one, but this one was made from an old center drill and it's very, very small, so when I need to get into these little spaces, it does work. Speaking of screws, I need a lot of them for this entire assembly. There are 16 screws in 4 different lengths, so my screw shortening fixture got quite a workout on this assembly. Here's all the final components for one footboard, and of course I have the same set for the other side. I did do a dry fit to make sure that everything is working, and then I know I'm ready for powder coating. So everything got cleaned up and over to my powder coating booth. I decided I might as well powder coat these now. Normally I powder coat in batches once I'm sure all of the pieces in a given area are built, because sometimes things need to have accurate fits that the powder coat might interfere with, but I'm 99% sure nothing high precision needs to attach to this footboard, so I think it's safe to just powder coat everything now and get it done. I did it in 4 separate sub-assemblies. The long footboard pieces went in by themselves, and then the 2 smaller brackets at the bolster end, I just bolted those together and powder coated them kind of as a unit. I try to powder coat sub-assemblies as much as possible, because it just saves you a lot of setup and baking time. You can get a pretty good pipeline going with the powder coating though. Each part is maybe 20 to 45 minutes in the oven, depending on how much mass it has, how long it's going to take to heat up to the flow temperature of the powder coat. So while you're baking one part, you can clean and set up and spray the next part, and then cycle them through. Off camera, I have a cooling rack set up that I can hang the parts from while they cool down and keep the oven free for the next part. All right, all the parts are done. Let's bolt it all together and see how it looks. As I was doing this, it occurred to me that I probably should have done this before doing all of the valve gear tuning and setup, because this structure actually adds quite a bit of rigidity to the motion brackets. So yeah, maybe I should have done this first, but I think it's fine. I mean, the motion brackets are also attached to the ends of the crosshead guide rails, so everything still seemed to work fine after bolting these footboards on. I don't think I messed anything up, but you know, food for thought. There's the footboards. This is a really good excuse to bring the boiler back in. We haven't seen it in a while. Just see how it all looks together. The footboards kind of run along the belt line of the boiler and are a really characteristic feature of any steam locomotive. Nice perfect spot there for Swarfy, and that is really looking like a boat now. I'm pretty pleased with how this bracketry all came out. The powder coating all came out really nice. No artifacts, no blisters, no fish eyes. It's surprising how much nicer actually those footboards make everything look. It's a very distinctive steam locomotive kind of feature, so it really yells the locomotive at you when you see footboards along the side of a boiler like that. And now we've got a great base to build all of the control linkages, so that is hopefully coming next time. Stay tuned for that. Thank you so much for watching. Thanks to my patrons for making this all happen every week, and I'll see you next time.